Yeah, that's right. Other guy's off clapping and jumping somewhere still, so I've got a studio. I've got another least common multiple greatest common divisor trick for you. We're going to start, of course, with some examples. What's the greatest common divisor of 6 and 9? Yeah, just 3. That's simple enough. Least common multiple of 6 and 9? 18. That's pretty simple too. Now check this out. What's 6 times 9? 6 times 9? 54. What's 3 times 18? That's right. 54. Maybe we got lucky. How about 20 and 28? All right, well, make sure we get this right. We'll go ahead and scribble down the prime factorizations. 2 squared times... forget this. We know a better way to do this. We factor. We're going to pull out a factor of 4. This is 4 times the GCD of 5 and 7, because there's a common factor there. GCD of 5 and 7, just 1, so this is just 4. Now, of course, that means least common multiple. Again, we factor out 4. 4 times the least common multiple of 5 and 7. Least common multiple of 5 and 7, it's just 35. So 4 times 35, 4 times 35 is 140. 20 times 28, let's check that out. 20 times 28, 560. 4 times 140. 2 times 140 is 280. Double that again. You guessed it, 560. All right. Once is lucky, twice is a coincidence. Let's try this one more time. GCD of 18 and 81, we're not going to go to that prime factorization nonsense. We're going to factor out a 9. We're going to pull out a 9 because they both clearly have a factor of 9. So that's 9 times the GCD of 2 and 9. GCD of 2 and 9 is 1, so this is just 9. Same deal down here. We're going to pull out the factor of 9 times the least common multiple of 2 and 9. Least common multiple of 2 and 9 is 18, so this is just 9 times 18. And that's 162. All right, let's check it out. 18 times 81. That's too much to multiply. But you know what? I'm going to pull out a 2 here. I'm going to write this as 2 times 9 times 81. Actually, I'm going to go ahead and put this 2 with the 81. 9 times 2 times 81. 2 times 81, that's 162. See what I did there? I got a little sneaky. I didn't even bother multiplying them out, and I see that 18 times 81 is 9 times 162. I multiply the numbers, I get the same thing as when I multiply the greatest common divisor and the least common multiple. I did it once, that was lucky. I did it twice, it was a coincidence. 3 times, we must be onto something. Let's see if we can figure out what's going on here. All right, so we'll start with a couple of different numbers. We'll start with 72 and 90. 72 and 90. Now, let's take a look at their prime factorizations. That is 8 times 9. 2 cubed times 3 squared. This, of course, is 9 times 10. 10 is 2 times 5. So we have 2 to the first times 3 squared, there's our 9, times 5 to the first. All right, so those are our 2 numbers. Now let's take a look at the GCD. To get the GCD of these 2 numbers, we go through and we find the lowest power of each prime in the prime factorization. Now to get a real close look at what we're doing here, I'm going to go ahead and drop in a 5 up here. 5 to the 0, of course, that's just 1. So for my GCD, I take the lowest power of a prime in each of these prime factorizations. So I want this one. And it doesn't matter which of the 3's I take. I'll take this one. And I have to take the lowest power of 5. I take that one. All right, so I get my 2 to the first. And because I like pretty symmetry, I'm going to go ahead and circle them down here. All my circled powers go together to make my GCD. Now let's check out the LCM. All right, LCM, now I'm going to take the highest power of each prime. Highest power of 2 is this 2 cubed up here. Again, it doesn't matter which of the 3 squareds I take for the LCM, so I'm going to take the one that's left here. And my highest power 5 is right there. 5 to the first. And once again, go ahead and box them down here too. It's my 2 cubed, my 3 squared, and my 5 to the first. And look at that. When I multiply the 2 original numbers up here, I multiply all these powers of primes. Now my GCD and my LCM, I have the same powers of primes. I just kind of jumbled up the order a little bit, but it's the same one. I take all the circled ones and I put it in the GCD. I take all the squared ones and I stick them in the LCM. So when I multiply the 2 original numbers here, I have the same powers of primes. So when I multiply the GCD and the LCM. So no matter what 2 numbers I start with, we can do the same thing. And we'll see that if you multiply 2 numbers, you get the same product as when you multiply their GCD and their LCM. And we're done.